Hello YouTube, and today we're going to find out how to convert between hexadecimal, octal and binary. Now on the screen, as you can see, is a hexadecimal value, and we're going to transform this value into binary first to begin with, and then from binary we'll convert it to octal. Now to some this may seem unfamiliar because in the human language we actually communicate numbers in a decimal format. So this really should say hex to binary to octal to decimal. Okay? Or whatever, whichever way around. In this case, we'll do from hex first, then binary, then octal, and then decimal. Okay. So AF16. To find out what AF16 is, we can refer to what's called an ASCII table. And this ASCII table is this table here. Okay, so you can go to www.ascii2table.com, and over here is a set of characters which has decimal, hex, octal, the character, which is sometimes used in programming and also in networking. So to sum up, we use this table both in networking and programming, and there are possibly other applications for it as well. So yeah, so we had two characters, didn't we? A and an F. So what's an A and an F? Okay, so in decimal, an A has a value of 10. Okay, and F has a value of 15. So that means that in a decimal format, this is 10 with 15. So okay, so what does that mean? What can we do with that? So if we go back to the value that we have, let's make a little table, and let's say that this is A and this is F. Okay, so A we know has a decimal value of 10. F we know has a decimal value of 15. So with that, what we can do is we can put it into binary. Okay, so how do we convert the decimal values of A and F to binary? Well, there's two ways that we could do it. One is by subdivision. So we can do 10 divided by 2, which is which gives us 5 remainder 0. So if I type remainder here, remainder 0, just correct remainder 0, and then we'll do 5 divided by 2, which is equal to 2.5. So that's 2 remainder a half. However, that half in binary is not valid. It has to be either an on or either an on or an off. Sorry. So an on is 1 and an off is 0. So 2.5, the 0.5 will be illustrated as an on value, so it's 1. Okay? So 5 divided by 2 equals 2 is actually 2.5 in decimal, but in binary, because it has a remainder of the half, it's characterized as being 1. Okay? So now 2 divided by 2 is 1, with the remainder of 0. Okay? Have I got that right? Let's see. 10 divided by 2 is 5. 5 divided by 2 is 2.5, so that's remainder 1. 2 divided by 2 is 1, remainder 0. Now let's check if I've got that right. So another way that you can check this is to go to a calculator and set it in Windows. Not sure if you can do this in Windows 8, but you can definitely do it in Windows 7. And all you have to do to get this mode is go to View, Programmer Mode, Alt 3. And then what you want to do is go to binary. I'm going to type in 0, 1, 0 in binary, and let's see what that is in decimal. That's actually 2, so I've done something wrong there. So what have I done wrong? Let's see, 10 divided by 2 is 5, remainder 0. 5 divided by 2 is 2, remainder 1. 2 divided by 2 is 1. Oh, I know what I've done wrong. I haven't said 2 divided by 1. That's what I've done wrong. And 2 divided by 1 is 0 in this case, remainder 1. Let's try that. 1 0 1 0. See if that turns out as 10. So binary 0 1 0 1. And that turns out to be 5. So I've done something wrong again. Okay, so if I just type in 10, what should the answer be? 1 0 1 0. Yeah, so that's what I've got there. See? Now, the thing that I forgot to say with this method is that, and the reason why I got it wrong actually, was because I forgot to do the division of 2 divided by 1, which in this case is 0. Remainder 1. Let's just check what that is in decimaler. Let's see, 2 divided by 1 should be 2, right? So 2 divided by 1 is 2. Yeah. 2 divided by 1 is 2, so the remainder is actually... So let's get rid of that. That's a mistake. Remainder 1. And we're not going to divide any further than... We don't need to divide any further than that. Hence, I put the 0 there. It's not a mistake to... It's not... It's just my way of saying that, okay, that's where the equation has ended, as opposed to carrying on and on and on and on and on. Because you don't need to carry on and on and on. You can just say that's 0. And then that can stop you from making a mistake. If not, you can say that's a 2, and then just put the 1 remainder there. As long as you know that that's where the equation ends, then for that particular method. So if I just call this method 1, and then that's it. If you want to double check this, there is another method. This is method 2, to go from hex to... Sorry, my mistake. Actually, I haven't finished with this equation just yet, so what I'll do is I'll finish with this equation first. So method 1 for 10. And now what I'm going to do is create another method. So I'm going to say method 1 for 15, because that's the value of f. Okay, so 15 is there. So we're going to do 15 divided by 2. 15 divided by 2 is equal to 7.5, so that's 7 remainder 1. And then I'm going to do 7 divided by 2, that's 3.5, so that's 3 remainder half, so that's 1. I'm going to do 3 divided by 2, which is 1 remainder 1. 1 remainder 1, and I'm going to do 1 divided by 2. I'm going to do... What else am I going to do now? Let's see, 3 divided by 2, which is 1, and then should I do 1 divided by 2? Which is 0, remainder 2. So I'm going to do 1 divided by 2, which is not a half, that's just a representation. 1 divided by 2, which is 0, remainder 1. Remainder 1. Now this is 4, 1. So I've done something wrong here, because that's not what the value should be. There should be a 0 in this somewhere. And the reason how I know this is because all ones in one octet is 255. So this should say that I'm wrong. So what have I done wrong? 15, let's check the value. Nope, it's 4 1s. Wow, I surprised myself there. Well, it's 4 1s. Fantastic. So 1 1 1 1. Let's just double check. 15, binary, 4 1s. Fantastic. Okay, so let's characterize this and put it into a table. So 10. So this is here we go. Let's make it a bit clearer. A, F, 10, 15, and this is 1 0 1 0. and this is 4 ones. 3, 4. Okay, now that's perfect because what that means is the division of a hex. Okay, when you have a hex number like this, you split it up into two parts of 4 on equal side, right? So what that means is like this. So you have 4. I'm going to call it. Shall I call it 4 bits? Am I correct in saying that? I'm going to call it 4 bits. So that's 4 digits. Let's call it, yeah. So that's 4 digits in for that part. Okay, so for A to F. So A has 4 values. Okay, either 1 or 0, and F does 4 ones. Okay, which just means it's all on. So that's it to binary. Okay. So A to F should be, the total binary should be, merge this table, 1 0 1 0 1 1 1 1. Okay, that's the total binary together. Okay, do the calculator. So AF to binary is, and as you can see, 1 0 1 0 and 4 ones. So that's one method to convert to binary. Okay, so this is the total binary. This is the total binary. This is partial binary. Partial binary for 15, for decimal value 15. Okay. This is the partial value for 10. This is the decimal weighted value. Decimal weighted value. Decimal weighted value according C2 table. This is just one part of the hex equation. Let's call it an equation for now. If anybody knows of a better thing to call A to F, then please let me know. I'm always open to comments. At the moment, I'm just a student, and this is just my particular way of tackling this kind of equation. Okay, so that's my way of doing A to F conversions from hex to binary. Okay, this is just the way that I kind of go about it. There may be other ways of doing it. I'm always open to comments as I'm a student. So yeah, this is one way. Which I'm going to do another way, which is maybe slightly easier in some respect, but it might not be. So what shall I do this? Okay, fine. Let's do like this. Okay, so we have A to F of 16, right? This means that it's hex because it's 16 base. Now in binary, oh, this is another thing that I forgot to mention. In binary, it's 2 base. Okay, base 2. So, as we know the values of the ASCII table, right, which is 10 and 15, what we can do is make a table. So if we make a 8 long table, right, and let's say this is 2, 2, 2, 2. As we have to split it into 4 to get the answer, so then we need to have 2, 2, 2, 2 there. Alright, I'm a bit nervous about this because I've often got this wrong, so bear with me on this. I will get the right answer, and we will use the calculator to check, just in case I've got this wrong. And then from that I can show you properly. So, let's have a look at this. So I think this is 2 to the 0, I believe that's 2 to the 1. No, not 21, 2 to the 1. This is 2 to the 2. Let's call this 2 to the 3. 2 to the 3. It's exactly the same thing here. 2 to the 3. 2 to the 2. 2 to the 2. 2 to the 1. 2 to the 0. Okay, so this is 15. Okay, so let's... okay. Let's put another table in, and let's merge this. Let's put that in there. Let's get rid of this. Okay, so if we just split the cell into 2 columns, we'll get, what was the first value? 10 and 15, right? So, now 15, okay, 15, the largest value is 8 and 7, right? So 2 to the 3 is 8, 2 to the 2 is 4, 2 to the 1 is 2, 2 to the 0 is 1, and same on this side, 8, 4, 2, 1. Okay, so the binary for this will then be 8 and 7, so it's 8, 4, 2, and 1, okay? Because 15, the decimal weighted value to binary, as you now know, is 4 ones, right? And we proved that back in method 1. So this is method 2. Okay, and we proved that back in method 1. So for method 2, okay, all I've done is that I've done the same thing, but essentially what I've done is I've used a table, okay, to the power of 2. So this is kind of, it's base 2, but because it's base 2 and binary is base 2, we can use this method, okay? That's all this means. So 10, the biggest number that will go into that is 8, and then the next number that will go into that is 1. So this is 0, and this is 0 because there's no value to it. And as you can see, have you noticed, look, it's 1, 0, 1, 0, 1, 1, 1, 1. Fantastic, isn't it? So what you can say then is that the total value is, again, 1, 0, 1, 0, 1, 1, 1, 1. That does look a bit small, doesn't it? So let's make that a bit bigger. How big is that? 11. Can't be 11. Oh, okay. Right. Let's see if I can make that a bit bigger. There we go. Okay. So, yeah. Okay. So, now that we know that, okay, what about if we wanted to do to octal, for example? Okay, so to octal, this is completely screwing this up, so let's go to octal. Okay, to octal, what we have to do is split the equation into 3s, okay? Right, so the best thing to do is take the binary value of what we found for A to F and split it into 3 parts. So 3 equal parts. Okay, we're going to split this into. So let's draw another table. Okay, 3 tables. So, okay, I know what I'll do. Let's make this into this. So to octal, we know that that's the binary. We know that there should be that this is, okay, because we can't see it anymore, I'm going to put the values back in. AF16. Okay, we know that this is 10 and 15. We know that that's the binary. Okay, so what we need to do now is actually split this and split this into 3 sections. Okay. Right. So, well, you may be thinking, okay, well, that's a bit weird because nobody really uses octal, and the second reason is binary usually goes up to 8 bits, so you usually have 1 octet, okay, in a binary. So hence, when you see 8 lots of ones, so 1, 2, 3, 4, 5, 6, 7, 8, this is equal to 255. No, not 1555, it's 255. Okay, and I can prove that by going to the calculator and having 8 digits of ones here. So look what happens: 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's for 1 octet. But if you have more than 8 ones, then that means you have multiple octets. So if I convert that back into decimal, 255. Okay. Now, what's the significance of 255? Okay, well, in networking, 255 is used for subnetting. 255 is used for subnetting. So if you're doing subnet calculations, then binary is really your bread and butter, because you need to know binary in order to do your subnet calculations. Okay? Right. So let's split this equation. So let's see. So we had 4 ones, right? So let's put 3 ones in here. Put 1 1 in there. See, so we had 101. Okay, so this is 101. So let's just split that up. Okay, yeah. So we have 101, and then we have 010. Okay. Now, where did that 0 come from? Right. What I've done is, to make it easier to split it into 3, what I've said is, okay, I'm going to split it up into 3 sections, and I'm going to introduce that 0. Now, it's not a problem to introduce a 0 because this is a positive number. Okay, and then basically, if we had another digit, am I saying that right? Yes. Okay, so basically, if it was a 1, I believe it goes into 2's complement. Now, 2 complements is when you deal with negative numbers. Let me just double check that for you to see whether or not I'm accurate. No, I don't need hotspot shield just now. See, can we have 8? Is it 8 or 9? So we have 1, 2, 3, 4, 5, 6, 7, 8. Right, okay. Okay, so I was wrong. That's not technically correct. Basically, all I've done there is introduce the next value because it's 9 digits, and 9 digits is after the first octet, so that's 9. Okay, that goes into the second octet. And because we have to split it into 3, all I've done is introduce a 0, and now that's valid because if you think about it as a voltage, it's an off voltage. So basically, it's saying that there's nothing there, which is what 0 means. So what all I've said is that there's nothing there. So, but I'm going to introduce you there just to make it a little bit easier for me to do the calculation. Okay, that's the only reason why the 0 is there. Now, if that was a 1, then this would be a completely different value and would probably mean that I have to do a different kind of calculation. Okay. So what I'm going to do now is I'm going to do the same as what I did back in this table here, or I can use the other one. Okay, but the principle is still the same, so you can still use this table to do this kind of calculation as well. Okay, but because it's binary, what you have to remember is that see, can I do it like this? Yeah, okay. So because it's binary, okay, what you have to remember is that you have to add the numbers of the ones. So in this case, this one here, right, is 2 to the 0. So that's going to be 1 plus 2 to the 2, which is 2 to the 1, which is 2, and then what is this? So this is 1. Okay, so it's 1 plus 2. Okay, because that's 2 to the 0. So because this is 2 to the 0, that's 2 to the 1, and that's 2 to the 2. Okay, so that's going to be plus 4. This is exactly the same process, so that's 2 to the 0, which is 1, plus 0, because there's nothing in there. And then that's 2 to the 2, which is 4. And this is 2 to the 1, which is 0, plus 2 to the 1, which is 2, plus 0. So, wait, 2 to the 1, which is 2, did I mean that? Yeah, actually that's fine, yeah, 2 to the 0, 2 to the 1, yeah, okay, fine. So, the octal will be 257. Okay, so the answer for that is 257 to the subscript of 8. Alright, let's double check that to see whether or not I got that correct. So, okay, so if I go to the hex mode, we say A to F, and octal 257. See? 257 to the 8. Alright, so that's how you do octal. This is how you do hex to binary to octal. So if I just put octal here, let's move that. Okay, what's just happened? Okay, let's say octal methodology. Okay, so that's octal. Okay, so say for example, we had let's see, decimal. Okay, so decimal to binary. All right, and let's say it was, I don't know, about 125. 125 base 10, right? 125 base 10. Okay, now decimal is usually in base 10. Okay, so a usual decimal is in base 10. Yeah. Okay. And to convert that into binary, what I'm going to do is take this table from method 2 and show you. Okay, so we have 125, right? $125. So what's 125? Well, it's 2 to the 6 and 2 to the 7. Okay, so this is 1 to 8, this is 64, this is 32, this is 16, this is 8, that's 4, that's 2, that's 1. Okay, so 125, the nearest number that will go into 125 is 64. Okay, now 125, so that's 64 minus 3, so 61, I think, is the closest number. 61, 125, yeah, so 61. So 61, the next closest number is 32. Now 32 minus 61 minus 61 is equal to 29, so 16 can go into there, that's 13. So I have 8, 4, and 1. So technically this should be the binary. Okay, so let's check whether or not I got that correct. So 125 is 0, 1, 1, 1. 0, 1, 1, 1. So 0, 1, 1, 1. 1, 1, 0, 1. Yeah. Okay, so there you go. So 1, 2, 3, 4, 5 ones. 1, 2, 3, 4, 5 ones. 0 and a 1. Okay. And yeah. So if you're wondering how I got 61, then all I did was I did 125 minus. What I did was I looked at which number in this table was the biggest value that goes into 125. So I did 125, and then I knew that 64 goes into 125 once, and that gives us 61. Okay, 61 is our remainder. So then what's the next biggest number? Okay, 32. So 32 into 61 is 29. Yep, 29. So 29, 16 goes into 29, and that gives us a 13 remainder. So 8 goes into 13, that gives us 5. And then 4 goes into it. 2 doesn't go into it, hence the 0, and then you get 1. Okay? And that's the number in binary. Okay? And yeah, there you have it. Binary to decimal, binary to octal. And then what do we say that we did? And then hex to octal. So say, for example, so now let's make it a little bit more complicated, shall we? Shall we say, shall we go from, see, let's go from decimal to hex, maybe? Or maybe, yeah, decimal to hex. Okay, let's get rid of this. I'm not sure if did I say decimal to hex? Okay, yeah. So let's carry this on. So let's go to hex. Right. So we know the value of the decimal. We know the binary. But what if we want it to go to hex? To go to hex, remember we have to split the binary into threes. Oh, sorry, binary into 4. So let's go and grab that table that I made back in method 2. That part. Okay. So we have to hex, we need to split it up into 4s, right? So what we know is that there's a 1 here. This is 0. There's a 4 there. There's an 8 there. Okay. Oh, sorry. My mistake. So we know that that's 1. We know that there's a 0 here. We know that there's a 4 here. We know that there's an 8 here. We know that there's a what do we know? We know that there's a 1 here. We know that there's a 2 here, and we know that there's a 4 here. Okay, so what's our total values? Oh, goodness gracious. Let's go back. Okay, so let's merge these 3 tables. Let's merge this 3. Oh, we know that there's nothing here. Okay. So what we need to do is 8 plus 4 plus 1, and then over here we need to do 4 plus 2 plus 1, and our total value is 5, and this is 13. Okay, so 13 is 5, so A is 10, B is 11, 12 is C, so this is D, which is 13, so 5D is our answer. Just calculate that, just check that on our trusty calculator, and let's see, 5D, and should give us 125, no it doesn't, give us 93. Okay, what have I done wrong? 125 in hex 70. Right, so I made a mistake here. Yep, see? See? That's how you can check how you made a mistake, you see? Because I've added it up. So this is actually 70. See? See, and I want to highlight that because that's a good way of checking whether or not you have a mistake. Whether or not you made a mistake. See? It prevents you from making a mistake. But in this case, I just didn't see it. So obviously I made that mistake, but I can rectify that by looking at that line here and noticing that this is actually a hex now. See? This is the hex for that. Okay, this is the original binary. Let's make this a bit easier to read. Let's insert a little blank table there. Alright. So that's the binary. That's the hex. Now what about the octal? How do we do the octal? Now remember, in octal, okay, what happened was that, oh dear, and you split this up into how many sections? 8 sections, I think. Split this up into 8 sections, right. Let's make a table there. Okay, so to octal, what we want is 3 separate sections of the binary. Okay, to split it into octal, what we need to do, okay, is to take the binary value that I found here, okay, which I copied from up there, and what I've done is I made a new table, and what we need to do is we need to split it up into 3s, remember? So let's split this up into 9 different sections, and oh no, that's each individual digit, so what I need is 3 blocks. Split it up into 3 blocks, and we should get that there. So 101, 101 is the first block, 3 3s in that block, and 101, 111, and we get 0, 0, 0, 1 in that block. So let's check 1, 0, 1 in that block, 1, 1, 1 in that block, 1, 0, 0. Yeah. Okay. And now what we can do is the same as what we did before. We just add the numbers. So that's 1 and 8. This is 1, 4 and 8. This is just 1. Okay. And what we get is 1, 13 and 9. Okay, so we have, oh gosh, that's an interesting one. What is that in hex? I'm sorry, in octal. So that's going to be, what is that in octal? Okay, so 125 in octal is 175. So I've made a mistake somewhere. I've made a mistake somewhere. Where have I made the mistake? Let's see, 0, 0, 0, 1, 1, 1, 1, 1, 0, 1. So that should be 2 to the 0, which is 1. This is 2 to the 0, which is 1, plus 2, plus 4. Okay, so that's 7. And this is 2 to the 0, which is 1. 2 to the 2, which is 4. 2 to the 3, which is 9. So it should be 179. Let's have a look. 175. Okay, so that's 1, 2, and that's nothing, plus nothing. So okay, so we have 2 to the 0, 2 to the 0, which is 1, 2 to the 2, which is nothing, 2 to the 3, which is 8. Now why does that come back as 5? Okay, let's split this up again. 101. Now 101 should be 5, right? It's what it's saying. So if I find debug for that in binary, convert it back to decimal, it says 5, yeah. So I made an addition mistake here. Okay, so 2 to the 0 is 1, 2 to the 2 is 0. Oh, it's 2 to the 2! See, that's my mistake. 5. It's 2 to the 2. Okay, because I've gone directly to 2 to the 3, which was wrong. I should have gone to 2 to the 2. You see, and these are some of the mistakes that you can make when doing the calculation. So as you can see, like even I find it a bit difficult sometimes to get this right. So I apologize for that, but I'm not going to edit it out because it can be a mistake that can happen when you're doing these kind of calculations. So it's useless for me editing out. But if you are bored of it or anything, then just skip. It's easier. So yeah. So there you go. Just like the calculator said, 175 octal. Okay, so that's 125 from decimal to hex to octal. Okay. So let's just get rid of that. Let's make this a bit more clearer. So it's 16 here. Get rid of that. Let's make this a bit more clearer. Let's call this 10. Okay. So I hope you've learned something today. This is kind of my method of doing it. Like you can have the two methods, like the method 1 up here, or you can have the method which is kind of like this to do binary. So this is what is this? This is hex to binary. Okay. Okay. So thank you for watching. Hope you had fun. Hope you learned something today. Also how to use Microsoft Word with superscript and a subscript. So that's a superscript, that's a subscript. How to make tables of different dimensions. So yeah, I think we covered a lot today, and hope to see you again soon. Also, please be careful when you're criticizing these videos, because I want to point out that I am a student. I'm still learning this kind of stuff, and I'm just showing you what I've grasped and how I'm learning these kind of methodologies, and how they relate to the course I'm doing in university. And have a good day.